Hi guys, welcome back. So what we're going to be looking at today is we're going to be looking at sketching linear graphs in slope-intercept form. So if you didn't know, that's when the equation of the line is in the form y is equal to mx plus c, where m is our gradient or our rise over our run. We also have c, which is our y-intercept. So this is the place where the line crosses the y-axis, in other words, when x is equal to 0. So what we're going to do, we've got three graphs here. So the first graph that we have is the graph of y is equal to 2/5 x minus 3. So let's write this out. So y is equal to 2 over 5 x minus 3. So we should already know, since this is our value c, this is going to be our starting point. In other words, our y-intercept. So we can write that as when x is equal to 0, y is equal to -3. The other piece of information that we need to know is we need to know the gradient. So the gradient, remember, is the rise over the run. Now, since our gradient is already in fractional form, we know that for every 2 that it's going to go up, that means that it's going to go 5 across. So I'm just going to add some extra tick marks into our graph here. So it's going to be a little bit easier for me to actually see where I'm drawing. All right, so I've just popped in some extra marks then. Let's break this down. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All right, so let's start off at -3. So that's going to be this point here. So let's put our first point or our first cross there. The next thing that we're going to do is we're going to use that gradient. So we know that the rise is 2 and that the run is 5. So that means we're going to go from this point here at -3. Let's draw that in. We're going to go up 2, so that's up 2, and then we're going to go across 5. So cross 1, 2, 3, 4, 5. So that is going to be roughly, and we've done it in a really poor spot, haven't we? That's going to be at this point here. Let's do it again. So we're going to go up 2, so up to here, and then we're going to go across another 5. So that's going to get us about here. All right, so let's get our line and let's draw that through those 3 points. Gosh, this is a bit of a mess, isn't it? So this is why we always do things with a ruler in our grid books and not just by freehand. Okay, so that's all we need to do is we've just drawn our line. We start at the y-intercept and then we use our gradient and we go up 2 and across 5. All right, let's do the same thing now, except let's do it with this second example. So what I've done, I've just refreshed the screen and then just fixed that line up a little bit so it looks a little bit neater. Okay, let's draw our second line now. So our second line is y is equal to -2x take 1. Now we already know that this is going to be our y-intercept. So in other words, c is going to be equal to 0, -1. Now our gradient, our rise over our run, is going to be equal to -2. So this is no longer in a fractional form. So we're just going to turn it into a fraction, and we can turn any number into a fraction by putting it over 1. Nice and easy. So what this means is instead of going up 2, we're actually going to go down 2 for every 1 that we go across. Let's do this in a different color actually. Let's do this in a red color so that we can see the difference with the lines. Okay, so we're going to start at 0, -1. So we're going to start here. And then we are going to go down 2, so down 2, and then we are going to go across 1. So we're going to end up at that point there. Now we could stop there and just do our 2 points, but I always do a third one just because I want to double check. So again, we're going to go down 2 and across 1, so that's going to be about there. That's a much nicer line, can I just say? All right, so let's draw our line now. So this is going to go through this way here. I'm actually going to write the equation of the line so that we know which is which. This is why it's so important to label our lines. Whoops. So y is equal to -2x minus 1, and then we should also label this line. So this was our first line, so y was equal to 2/5 x minus 3. All right, I'm going to reset and I'm going to come back in a different color for you. All right, I'm going to do this last color in green, so sorry for all of you colorblind people right now, but let's do this. So y is equal to -0.3x plus 0.5. All right, so let's start off with our y-intercept. So in other words, we're going to start off at 0.5. And now with this one, this is a decimal, so this is really easy to turn into a fraction because, again, all we need to do is we just need to put it over 1. Now, I don't like having this decimal, so I'm just going to times the top by 10, and since I'm timesing the top by 10, I should probably times the bottom by 10 as well. And so that's how I end up with my fraction. Really simple way to do it. Okay, so now we can see that our rise is going to be -3. So in other words, we're going down 3 for every 10 that we go across. So let's draw this line now. So we're starting at 0.5. So that's going to be about here. We're going to go down 3. So since we're at 0.5, we're going to go down to -2.5. And then we're going to go across 10. So that's going to be about here. Now for this one, I'm actually running out of space. So what I'm going to do is I'm going to work backwards. So I'm going to go actually up 3 and then across backwards the wrong way. So we're going to go up to about 3.5 and then we're going to go backwards to about here just to make sure that I can actually get my 3 points in. And so then I'm going to draw my line through. Now this one, for all you colorblind people, is a slightly thicker line, but just in case you can't see it, I'm still going to label it. So we have y is equal to -0.3 x plus 0.5. Okay, so that is how you draw a linear equation using the slope-intercept method. So for this one, you really need to make sure that it's in slope-intercept form. With the gradient, it's always the rise over the run. So if you don't have it in that fraction form, turn it into a fraction by putting it over 1, magic trick, and then start at your y-intercept or start at C. All right, so I want you guys to have a go at that now. So this is chapter 3.2 in your books, page 79. And again, we're just going to practice the first column. So y is equal to 4x plus 1, y is equal to -5x minus 4, and y is equal to 0.6x plus 5. And we're going to come back and we're going to do our last method in this video. So I'll give you time to pause now. Okay, so let's go through this last one. This last one is actually the craziest one, but at the same time, it's also the easiest one there is. So we're going to graph linear equations that are actually constants. So what do I mean by constant? I mean something that does not have a variable attached to it. So in other words, it's just going to be like x is equal to a number, or it's going to be y is equal to a number. It's not going to have a gradient or a slope or anything like that. All right, so let's start off. Let's start off with a really simple example. So let's start off with y is equal to 3. Okay, so y is equal to 3. It doesn't actually matter what the value x is going to be, because whatever value x you substitute in, you're still going to get y is equal to 3. It's not going to make a difference. So if I was to plot this as points, I would plot this as 0, 3, 1, 3, 2, 3, 3, 3. I guess you can see where we're going with this, right? And we end up with a horizontal line. So in other words, we just end up with a line horizontally crossing through y is equal to 3. Really easy, okay? We could also write this in slope-intercept form for this one. So we could write this as y is equal to 0x plus 3. So again, you can see that with this one, there is no slope. Now, this is where it gets a little bit weird. So we've always had y is equal to something. Now we're saying x is equal to something. So in this case, x is equal to 10. And again, it doesn't actually matter what y is, because x is always going to be equal to 10. So if y was equal to 0, x is 10. If y was 1, x is 10. If y is 2, x is 10. So we can plot these points. And what we actually see now is we actually see something a little bit different or a little bit strange. And that is a vertical line. And the reason that a vertical line is so strange is because with the vertical line, it doesn't actually have a slope that we can define. So we call this an undefined slope. So I can't actually write this in y equals mx plus c form, right? Because we just have x is equal to a number. We don't actually have a gradient and we don't actually have a y-intercept. It's not crossing through that y-axis whatsoever. The reason that the slope is also undefined, by the way, if you think about the original definition of slope, so rise over run, let's say I pick between these 2 points here. Whoops. So let's do from that point to that point. And so let's say that's gone up about 3, right? And it's gone across 0. So what's the problem with dividing by 0? Can't divide by 0, right? So we effectively do not have a slope because the slope is undefined at this point. So these are really simple lines to draw. So you just got to remember, it's kind of like counterintuitive. Y is always going to be a horizontal line and X is always going to be a vertical line. All right, so what I want you to do is I want you to sketch those last couple of graphs now for me. So y is equal to negative 20, y is equal to 35. So those are going to be what kind of line? Horizontal, good. And then we're going to draw those last 2 x graphs as well, which are going to have vertical lines. All right, talk soon. Bye, guys.